Because you're on page 1 here. What? Yeah. Did you skip a page? Yeah.
Can I rip it out?
Yeah. I'm sorry. Your fish died? Oh, that's it. Sorry. sorry. My what kind of fish? A goldfish. My parents had a goldfish for like 4 years. That's why I left. My uncle had one for like 6 years, and it was like big. And then my uncle was helping by cleaning. He cleaned out the fishbowl and used bleach. Fish died. And then my dad's fish, I think, committed suicide. He ended up jumping out and like died right away. Yeah.
The first fish I got, like one of them was bigger than a million. I fed them a lot. Like
one is bigger than the other. One usually eats more than the other. You know, when you overfeed them, half the food goes to the bottom anyways. Yeah. Or they die from overeating.
Well, they could look.
Yeah, when I was like...
Oh. Alright, let's do this. Yesterday's homework was easy, yes? Hopefully.
Can I do it on the back?
Yes. I don't like starting on backs. It makes it ugly. This is going to be a front and back page. Do you know what I mean?
Yeah.
Alright, so counting principle and permutations. Alright, so I'm going to teach the counting principle. I'm only going to start you on permutations today. I'm mainly going to show you how to solve it mathematically. I'm not going to tell you the word problems that go with it yet. That'll be tomorrow, along with combinations. So today is just counting principle and then very basic permutation part. Okay? I know, I'm speaking another language. We are. So what is the counting principle? And how do I compute permutations? Alright, counting principle. I'm not going to give you a crazy definition, I'm just going to give you a little short one. Counting principle is used for the possible combinations. You're trying to find out how many combinations can be formed. So we're trying to figure out the number of combinations that can be formed given a certain amount of stuff. All right? So we're going to do an example, and our example is going to say this. I'm going to explain it more than I'm going to write it. It says, let's pretend we packed a suitcase, right? And in our suitcase, we packed some clothes to go somewhere. Now, we're not worried about fashion. We're not worried about what matches, really, okay? We just packed some items. And my question is, how many outfits can you make per your suitcase? Do you understand? So based on your suitcase, how many outfits can you make? Not worried if it matches or not. Do you understand? So in our suitcase, we have 4 pairs of pants. Those pants are blue, red, black, and green. Our suitcase also contains 3 shirts. Those shirts are red, white, and black. Our suitcase also contains 2 pairs of shoes, and they're just black and white. So the question is, how many outfits can we make? Do you understand? So we're asking ourselves how many outfits we can make. All right, so we're going to start with what we're given first. We're starting with blue pants. So I'm going to take my blue marker. I like that blue. All right, we're going to take blue. And we're going to make what's called a tree diagram. I didn't do that right. And we're going to diagram out what we have, right? So let's think about this. Ready? If I have blue pants, I can wear a red shirt, I can wear a white shirt, or I can wear a black shirt. I can't wear another pair of pants because I already have pants on, right? So I can have blue pants with a red shirt, with a white shirt, or with a black shirt, correct? So it's either red, white, or black.
White.
Right? Does that make sense? Okay. Now, depending on what shirt I have on, how many options do I have for shoes? I only have 2. I either have black or white. I have black or white. And I have black or white. So let me tell you what this says. This says I can wear blue pants, red shirt, black shoes. I can wear blue pants, red shirt, white shoes. How many outfits is that? It's 2. I can wear blue pants, white shirt, black shoes. Blue pants, white shirt, white shoes. You see how this works? Got it? All right. So now we're going to do the next color. What are my next color pants? They're red. So we're going to make a tree diagram for our red pants. And what are our color shirts that we have? Red, white, and black. And how many shoe options do I have for each outfit? I have 2. So if I have a red shirt on, I can still wear what color shoes? Black and white. Black and white. Black and white. Yeah? Does that make sense? Go ahead and do green and black next. Ready? You should have, for black, you should have red, white, black, black and white, black and white, black and white. Yeah? And then the same thing looks like it's here. Yes? Makes sense. All right. So I'm going to count up how many outfits I have. You ready? I have 1, 2, 3, 4, 5, 6. You understand? Well, if I count the bottom, there's 1, 2, 3, 4, 5, 6. See how that works? How many are here? Oh, there's still 6. And here? 6. And here? 6. So if I add them all up, how much is that? So I have 24 outfit options. Correct? Does that make sense? Okay. So, looking at my problem, I started with 4 pairs of pants, 3 shirts, and 2 shoes. 4 pairs of pants times 3 shirts times 2 shoes is how much? It's 24. Okay? So we're going to give another option. I want you to make 1 tree. So I made 4 trees here. Do you notice how the trees just kind of repeated itself? So I'm going to have you make 1 tree, and then you're going to figure out how many options you have. Understood? All right, so example 2 is going to talk about sandwich options. So let's pretend we go to Subway. We're only going to have 3 bread options because Subway has a lot, but we're only going to have 3 bread options. Our 3 bread options are going to be wheat, white, and flatbread. Okay? You have 4 meat options. They're ham, turkey, salami, and tuna. You have 4 cheese options. They are American, Swiss, cheddar, and provolone. What about what? We're not getting crazy here. We're going to have a very plain sandwich. I don't want to go into crazy. Like, we'll be here forever if we do, like, all the toppings. Toppings are, you can still add toppings later, but we're not worried about those. We're just worried about the meat, bread, cheese option. Okay.
Wait, what's after American?
American Swiss, cheddar, and provolone. All right, so I want you to make 1 tree. Does it matter which bread you start with? No. You could start with wheat, white, or flatbread. I don't really care. You're going to make 1 tree. Diagram, go. Okay, ready? Okay. If you made one based on wheats, you should have 4 marks coming out of it. So you should have ham, turkey, salami, and tuna. Yes? Okay. Then you should have 4 cheese options. 4 cheese options. 4 cheese options. And then 4 more cheese options, which are American, Swiss, cheddar, provolone. American, Swiss, cheddar, provolone. American Swiss, cheddar, provolone, American Swiss, cheddar, provolone. How many options do you have total on this one type of bread? 16. How many types of breads do I have? How many do you have total? Very good. Makes sense? So, the reason why I showed you this is because some of you think a little bit better if you can draw it out, right? Your brain just works that way, especially in the very beginning. You're like, well, let me just draw out 1. But if I drew out 1, I see I have 16. And then I know there's 1, 2, 3 options, so multiply that by 3, there's my total. Still, that's just in case you forget how to do this, because sometimes you're like, well, I know I'm supposed to do something with these numbers, because it changes along the way. It's the same thing as saying 3 times 4 times 4, which is also 48. Okay? So I've shown you a couple ways. Like, yes, you can make the chart the whole way out, like number 1. This one, you can just make one of them, and then multiply. Or you can just multiply. But when I switch up the options, it starts to change, okay? And what happens is you guys start to get confused in your rules, right? So if I'm just talking basic options of putting together, I can always think of the tree in my brain, which means I'm just going to multiply. Got it? Let's talk about permutation. Does this make sense? It's pretty easy, yeah? How many of you are like, okay, so far so good? I'm telling you, some of you, second semester is easy. It's up to you. I'm going to write out some stuff and solve, so maybe. All right, we're going to talk about factorial. Factorial. That's an R. Factorial. Factorial you may have seen on a calculator. You may have seen it somewhere. It looks like an exclamation point. It doesn't mean that we read the word 5. No, it just means it's 5 factorial, okay? So I need to know what it means. It means we multiply. From the given number down to 1. We're going to multiply from the given number down to 1. Bless you. Ready? We're going to do it. We're going to take an example here, and we're going to say 5 factorial. And I want you to watch the magic. So what does it mean to be 5 factorial? It means that we take 5, and we're going to multiply by 4. We're going to multiply by 3 all the way down till 1. So 5, 4, 3, 2, 1. Multiplied together. This isn't that big. So we can multiply 5 times 4, which is what?
40.
Multiply that by 3. 60. Multiply that by 2. 120. Multiply that by 1.
20.
Still 120.
Wow.
Wow, look at that. Okay? We good? So now I want you to do 8 factorial. 8 factorial. You might want a calculator.
Oh, shoot. Oh, no, this is easy.
Hi, freshmen. If you haven't heard, Cocoa and Cram is tomorrow and Thursday after school in the cafeteria. cocoa and cram.
What is that?
It's for the freshmen to come study for their finals.
Oh, I'm gonna go.
Sorry. Because they're freshmen and we have link crew. Yeah, sophomores got it last year.
You only get it 1 year.
You get it 1 year.
Do we count 0 too sometimes?
No, 1.
Never?
No,
Oh, zero's the number.
no. Not for this.
Never. No.
They know all
What'd you say?
the 0.
Yeah.
Are you feeling sorry for yourself because you weren't here?
Every answer will be
Sorry.
0.
Yeah.
I'm sorry. Yeah, that's
Freshmen get something special. And then when you're not a freshman, you don't get it again. Like my link crew leaders,
Can I see the answer?
lead the freshmen. But can you see the answer? Not yet.
But can I say it though?
Oh, I deleted an email. Not yet. Ooh. Why does Starbucks get to send me emails? Yeah,
because they want you to go.
I know. Especially when they tell you there's like a new blonde espresso. It's not bitter. That's my favorite part. All right, ready? We get 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. You should have wrote it out, yeah? So you don't have to show me the word because it's a really big number. So what's your answer?
40, 32, 0.
Say it correctly.
40,320.
Very good. 40,320. We good? Makes sense?
That's how much money I'm gonna
No, you have to write it out. You don't have to just multiply it out. Just let them. Are you like this at home?
Huh?
Are you like that at home?
Yeah.
How many siblings do you have?
2. But they're older.
Oh, okay.
But I got 1,000,000 cousins. We're all like this.
What'd you do wrong? Did you multiply wrong? Let me see. Did you clear your calculator? Because if you didn't clear it, you can arrow up and figure out what you did. All right, permutations. Permutations. It is a number of R objects. In a group of n distinct objects. It is a number of R objects in a group of n distinct objects. Distinct. There might be a C at the end, yeah? Right here. CT. And it has specific order. I can spell as long as I don't copy my old spelling that was wrong. I'll talk about order more tomorrow. Today we're just going to talk about how to solve it mathematically, okay? So we're just going to do the mathematical computations. We're not going to worry about how to actually solve the word problems that go with it. If you haven't picked up on me saying it, this whole unit is word problems. Okay? Starting today. It's easy. All right. They're not that hard. Well, then you better, because you're going to fail this unit. Some of my kids last year, this was just like their best unit. One of their best units. This one and the trig unit. Like Sierra, this was like one of her best units.
Just thankful there's no graphs.
All right, n is the total number. R is out of total number. is equal to n factorial over n minus r factorial. So tomorrow you're going to learn how to plug this piece in. Today you're going to learn how to solve this piece. Okay? So, I'm going to give you a problem. And our problem is going to say 6 permutation 3. P stands for permutation, so 6p3 is permutation. So 6 permutation 3. And I want you to watch this part, okay? So here we go. We know that this is n and this is r. So if I'm looking here, the first number is my n, so it's 6 factorial, correct? Over what goes on the bottom, 6 minus 3 factorial, right? Make sense? Okay. Now, what I want you to know is this. If I subtract on the bottom, 6 minus 3 is what? It's 3 factorial, correct? Does that make sense? Okay. On the top, though, I want you to watch, and I'm going to explain where it comes from. I'm going to go ahead and write 6 times 5 times 4 times 3 factorial.
Oh.
Why did I stop?
Oh, because the bottom is 3.
The bottom is 3. What does it mean to be factorial? 3 times
2
times
1.
Isn't that the same if I keep going here? Isn't that 3 times 2 times 1? Right? So, in case this doesn't make sense, you're like, I don't know what you're talking about, Resendez. This is what it means. It means 6 times 5 times 4 times 3 times 2 times 1. Right? It also means that you have 3 times 2 times 1. Correct? Because 3 factorial is 3 times 2 times 1. And 6 factorial is 6, 5, 4, 3, 2, 1. Well, if these are exactly the same, they're going to cancel. So I could stop it and cancel it. If I don't remember that, can you do this?
Yeah.
Yes. But I'm showing you for some of you that are a little bit faster and then you're like, why am I writing this all out? You can stop it. All right? But if you don't remember, you do it this way. Yeah.
So when you get your 6 times 5 times 4, you just leave it?
We're going to multiply it.
Yeah. That's it?
Yeah?
Oh, okay.
So you're going to multiply 6, 5, and 4,
It's too easy.
which is how much? It is 120. And guess what? Now I'm done.
Wait, what happens if the top is smaller?
It won't be.
Never?
It can't be, because if you notice the first number is, this is what it's saying. You have 6 people,
Oh, I get it. Yeah.
and I'm picking 3.
No, I get it, but I was just saying, like, what if... Like,
It can't be,
Oh, okay.
because I can't